just 3 synapses. So 3 separate synapses. So that's the postsynaptic membrane. Those 3 are the presynaptic membrane. What we're doing is, once again, we're measuring membrane potential in the postsynaptic membrane. That's what we're doing. No different than what we were doing here. All right? Except the story's a little bit more complicated than that. Each of these synapses is going to have neurotransmitter released. And I'm going to say that when the neurotransmitter in synapse A is released, that we're going to get a 2 millivolt EPSP, meaning membrane potential is going to change plus 2 millivolts. I'm going to say that in B, it's going to cause a 3 millivolt EPSP, and in C, I'm going to go with -2, so a 2 millivolt IPSP, okay? We're going to measure again the membrane potential in that postsynaptic cell. That postsynaptic cell is going to have a resting membrane potential, just as we see there, so that's resting, we know that. Let's say that neurotransmitter A is released all by itself. What kind of a change in membrane potential are we going to get? How big is the EPSP going to be? 2 millivolts. Okay, there's nothing tricky about this. So we're going to get a plus 2 millivolt change. That is not summation. With summation, to add something, you need at least 2 numbers, right? So that's not summation. Now what I'm going to show you is summation. Let's say that at the exact same time, neurotransmitter A and neurotransmitter B are released at the exact same time. Now we're going to have an additive effect. What do you think the change in membrane potential is going to be when A and B release a neurotransmitter at the same time? It's not tricky. 5. That's summation. When more than one synapse releases its neurotransmitter at the same exact time, we have what's called spatial summation, by the way. Spatial summation is when there is more than one synapse involved in the summation. But you don't have to have more than one, by the way. You can just have one. That's what temporal summation is. I'll talk about that in about 2 minutes. All right? So A and B at the same time. Again, you need 2 numbers at least to add, 2 or more. By the way, remember that. That sounds simple, doesn't it? How many numbers do you need to add? At least 2. All right? There's going to be at least one question on the exam where some of you are going to get it wrong. You're going to come to my office, you're going to look at the exam, you're going to ask me, well, why wasn't answer A right? And I'm going to say one thing to you. How many numbers do you need to add? And as soon as I say that, you're going to get why you got it wrong. All right? Hopefully nobody will. That's my hope. But it usually happens. All right? Now, I ask you, what if A and, how about B and C? So B and C release their neurotransmitter at the same time. What kind of a membrane potential change are we going to have? Plus 1, right? Plus 3 minus 2 is plus 1. See how simple this is? That's summation. All right? We'll do 2 more. A, B, and C. What's the membrane potential change going to be? A, B, and C, it's going to be plus 3. Plus 3 plus 2 minus 2. So that this cancels this out. That's summation. Okay, so we're at plus 3. We'll do 1 more. How about A and C? A and C. What kind of a membrane potential change are we going to get if A and C are released at the exact same time? A and C. Nothing. Sometimes that happens. Sometimes the membrane potential does not change. They can cancel each other out. This neurotransmitter causes a 2 millivolt EPSP. This one causes a 2 millivolt IPSP. Membrane potential will not change. That's completely possible. That is spatial summation. More than one neurotransmitter being released at more than one synapse at the exact same time. It's just math. All right? So that's spatial summation. How about temporal summation? With temporal summation, we only have one synapse, but we can still summate. And I'm going to show you how. So again, we're going to measure the membrane potential in that postsynaptic membrane. we're just going to have neurotransmitter released here. And I'm just going to keep it simple. I'm going to say it's going to cause a 2 millivolt EPSP. I could have made it a 3 millivolt IPSP. I could have made it whatever the heck I wanted. I just chose that number. All right? So we have our action potential that comes down and eventually causes the release of that neurotransmitter, and we get a 2 millivolt EPSP. That's, again, not summation. But this can happen. These action potentials that are coming down. Can you have another action potential come right after that action potential in a very close period of time? Absolutely you can, right? If the frequency was really high, we went over frequency, correct? Let's say that an action potential came down and caused the release of neurotransmitter. By the way, is all the neurotransmitter released? With one action potential, is all of the neurotransmitter released? Absolutely not, it is not. That's why when we drew this, I didn't have all of the vesicles moving to the edge of that membrane, because not all of the vesicles do. There's plenty more vesicles. There's plenty more neurotransmitter that can be released. So if you have another action potential come in very close proximity to the other one, I'm going to get double the release of the neurotransmitter. So now what's the change going to be? Not plus 2, but a 4 millivolt EPSP. You're going to get twice as much neurotransmitter released. And then if you have 3 very close in time, it's going to be 6. That's summation. This is, that. The first one is not. That's temporal summation. 1 synapse, all right? With lots of it, and it doesn't have to be a lot, but more than 1 action potential coming in very close proximity to the previous one. It could be 3, 4, 5, 6, 7, 8, 9, 10. Action potential propagation conduction is really fast compared to all of these steps here. Okay? It's just that simple. All right? If you can add little numbers like 2 and 3 and subtract little numbers like 2 and 3 and 1, you're going to be fine on the exam. If you understand this, and if you can remember, you need more than 1 number to summate. If you forget that, you're going to get these questions wrong. I guarantee you will, because I've seen them. All right, simple sentence. You need more than 1 number to summate. Write it down. Okay? Are we good? Yes? All right. Now what? And we're going to talk about that again. Okay? Let's talk about this for literally 30 seconds, because I'm going to talk about this again later on in the lecture. When you see the word plasticity, and it's used in conjunction with the body, what it means is the ability to change. All right? Plasticity means the ability to change. What's changing? In this case, the synapse. What can change at a synapse? Well, you can release more or less neurotransmitter because of some event. That's plasticity. You can have more receptors or less receptors. That's plasticity. There was a change. What was the change? The number of receptors. You can have more or less synapses. That is also plasticity. Okay? So anything that changes at the synapse is considered plasticity. And that's all I'm going to say about it right now. All right, we're going to talk about it again at least a couple of times in the next hour. Okay? Good? All right. Now let's talk about 11 neurotransmitters. Okay? About 20% of the number of neurotransmitters that you have in your body. There's 50, 60 of them, if not more. We're going to start with acetylcholine. So this is a list of neurotransmitters. Acetylcholine, there's 3 monoamines. There's a few amino acids we're going to talk about, a couple of neuropeptides, and 2 gaseous neurotransmitters. We're going to start with acetylcholine, the very first neurotransmitter ever discovered. This is what I want you to know. I don't really care right now if you know where the neurotransmitter is located. If it's central nervous system or peripheral nervous system. What I do want you to know, though, is excitatory or inhibitory. When we excite the cell, what are we doing to the membrane potential? We're making it more positive. When we inhibit a cell, we're making it more negative. So when we drew these EPSPs and IPSPs, excite, inhibit. There are some neurotransmitters that do this, there are some neurotransmitters that do this, and there are some neurotransmitters that do both. Acetylcholine is an example of a neurotransmitter that can do this and can do that. It's a neurotransmitter that can excite some cells and inhibit other cells. Well, how is that possible? Acetylcholine is acetylcholine. It depends on the cell. It depends on the postsynaptic membrane. It depends on the stuff that's happening inside of the cell. All right? I'll just give you a quick example. That's a skeletal muscle. That's the muscle that you're going to be learning about in a lot of detail very, very soon. The muscle that's attached to your bone. That is a cardiac, and by the way, that's what they look like. They look like a piece of string under a microscope. Looks like a piece of thread. That's a cardiac muscle. That's the muscle in your heart. Your nervous system controls both of those through a chemical synapse. We're going to release acetylcholine onto a skeletal muscle. We're going to release acetylcholine onto a cardiac muscle. It's the same acetylcholine, it's just two different cells. What does it do to skeletal muscle? It excites it, it depolarizes it. What does it do to a cardiac muscle? It inhibits it. It hyperpolarizes it. It's the same acetylcholine. So what makes it different? The stuff that happens inside of those cells is different. All right? So when you see excitatory or inhibitory when it comes to a neurotransmitter, understand what it means. EPSP, stimulate, depolarize, causes action potentials, all that stuff goes hand in hand. IPSP, inhibits, hyperpolarizes, all of that goes hand in hand. And hopefully I've hammered the hell out of that by this point to where you do know what that all means, okay? So know that acetylcholine is a neurotransmitter that can excite and inhibit. It's not going to do both things to the same cell. It'll do different things to different cells, depending on what cell it is. So I want you to know that. I want you to know what it does. And by the way, the stuff that I have you guys know when it comes to these neurotransmitters is not an exhaustive list. There's a bunch of other stuff. We can study acetylcholine now for another 10 years. That's how much stuff that it does and that we don't know it does. This is just a list that I'd like you to know. Acetylcholine allows you to learn the material that you learn. If you don't have enough acetylcholine released in your brain, you don't learn as well. How do we know that? Alzheimer's disease, I'll talk about it. Okay? So it's important in memory. It allows you to sit there and pay attention to what I'm saying right now. Okay? Helps you sleep properly. It's good for arousal. I just showed you what it does to skeletal muscle. It stimulates it. I just showed you. Okay? And it does a bunch of stuff in your autonomic nervous system that we're going to talk about in about a week. Okay? So know that it's excitatory or inhibitory, and know these general functions. And we're gonna visit this one right here, memory. I'm going to show you Alzheimer's disease. We're going to draw Alzheimer's disease, and I'm going to show you how to treat it. This is a postsynaptic membrane of a neuron in the brain. And we're going to have a number of synapses here. We'll just draw 3. And we're releasing acetylcholine in each of those. Okay, so that's acetylcholine in each instance. All right? And I'm going to say that at each of these synapses, it's exciting. All right? It's excitatory. I'm going to say it's 2 millivolts. Okay, that's the membrane potential change due to the release of acetylcholine at that particular part of the membrane. Okay? So, let's just say all of these synapses release that acetylcholine at the same time. What's that called, by the way, if that happens? Summation. Tell me what kind? Spatial, because it involves more than one synapse. So we're seeing spatial summation right now in action. And this acetylcholine that's being released onto this neuron right here is allowing you to learn right now. This is happening in your brain right now. All right? So right now, under normal conditions, the way that I have it drawn, the signal is what? Plus 6 millivolts. Can you see that? 2 plus 2 plus 2 is 6. All right? There's Alzheimer's disease. Alzheimer's disease is a disease where the neurons in the brain are destroyed, okay, because of the formation of these amyloid plaques. It just eats the neurons. And so now we no longer have the release, this is Alzheimer's, the release of that neurotransmitter by that synapse or that one because those synapses no longer exist. What's our signal now? Is it 6? What is it? It's 2. Now you forget stuff. Now you forget why you are in your car driving to where you're going. You forget why you walked into this room. You keep misplacing